Dr. Clark coming back at you, and in this video we're going to do a couple examples where we look at study design, particular with paired design, and see how to use paired design to get higher quality statistics. Let's take a look. So the example problem we're looking at is, can you study with music blaring? Okay, some students like to study with music playing. Is that actually a good way to help them study or not? That's one of the questions we've got. We're going to refine that down a little bit and to focus on, should you study with music with lyrics versus music without lyrics? Does the presence of those lyrics interfere with our ability to memorize? Okay? All right. So one way you could do this is you could get two classes of students, for example, and you could have one class listen to the music with lyrics, and then the other class listen to music without lyrics, and test their memorization and see, record the scores and see what group, what class has a higher score in their memorization. And this would be called an independent study or independent groups design, because you've got two independent groups. One group gets the treatment A, one group gets treatment B, which is music with lyrics, music without lyrics. And then and then you just compare the average memorization score for one group and the average memorization score for the other group, and then see if there's a statistically significant difference between the two groups. That is not a paired design, that's two independent groups. So how could you take this same kind of setup and upgrade it into a paired design? Because remember, we saw in the last video that paired design reduces the variability, which might mean we can get stronger inference. So here's a paired design that uses repeated measures. In this case, all the students would be tested twice under both conditions. So in this case, you would test every student with music with lyrics and every student with music without lyrics, and then you would focus on the difference in number of words memorized. So you would have maybe a minute to memorize words with music on, get tested on your memorization, then another minute to study a different list of words to memorize, and then, but music had lyrics on that time, and then see how many they memorized, and look for each person, how much of a difference did it make. And this design is better in certain ways because you get, it's just the same person in each group, right? The same person gets tested twice, so that person has a certain amount of memorization ability, and then you get that same person with music with lyrics and with music without lyrics. And so probably you might actually be better able to test the difference between the two groups compared to the other design where you just had two separate groups. Because maybe just by random chance this group got all the good memorizers and this group didn't, and so there's some confounding variables there. Now, if you randomly split the people into the two groups, that would help out with that. But this paired design where the same person's tested twice, that focuses on the difference in number of words memorized. Okay, so a hypothetical scenario here to kind of give you an idea. Let's say this is the music with lyrics and this is the music without lyrics, and this is how they memorized. This person got a 3, and then maybe later on they got a different number or whatever. All right, now in this case, what if every student remembered exactly 2 more words when they listened to a song with no lyrics? Well, there's a lot of overlap in the data, so are you going to look at this and say like, oh, it's clearly this is more memorization than this, because it doesn't, that's a little bit more, but is it really that much more? But if we pair them up and subtract, and it's 5 minus 3 is 2, and 9 minus 7 is 2, and 15 minus 13 is 2, when you plotted the differences, they would all be 2. And there would be clearly, it would be clear that they memorized 2 more words this way. But this is the exact same data. This would be just unpaired, and then this is paired where we subtracted the 2 and just got 2 every time. And so you can see how much variability. Look at all the spread here and here. Now there's no spread. Now that assumed that every student got exactly 2 more words, but this is what happens when you do paired design, is you remove all of the variability within the group and just focus on one person to that same person. And when you do that, you can a lot of times get tighter data. And this would be extremely strong evidence that non-lyric music allows you to memorize more words. Okay. A couple other ways to look about it. You could, if we see an improvement in memorization, is it attributable to the type of the song? Could you get a cause and effect? Well, it would depend on how you set up your experiment. In this case, when you had the same person listen to both, the only difference would have been whether they had music with lyrics or without lyrics. So it should be a cause and effect situation there where you could conclude that if that was the only difference between the two things. Although when you start thinking about confounding variables, if you played the music without lyrics first and then the music with lyrics second, maybe they got better, or maybe they got tired and got confused, right? So there's a question of, do you get better the second time around, or maybe you get tired and you get worse the second time around because you got all the words from the first list jumbled into your brain. So that can be a confounding variable, although you could randomly assign whether they hear the lyrics first or second, and then that would sort of cancel that out, or at least spread it around between the two groups. All right. And then the third possibility is a paired design that uses matching. And in this case, you would first test all the students on memorization ability with no music. And then you would match students together in pairs who had similar memorizing ability. So you'd match a 4 with a 4, and a 5 with a 5, and a 6 with a 6. And then for each pair of students, one pair would have music with lyrics, one pair would have music without, and then you could compare the two groups, not as independent groups, but rather as pairs of students with a single difference. And that actually would be a pretty good way, because it wouldn't, it would get rid of that confounding variable of learning, because there wouldn't, both students would have the same background. And this design is sometimes useful when you can't retest. Like in this example, with music, we could retest the memorization activity. But you can't perform two surgeries on the same person. So if you want to know whether one surgery technique is better than another, you might want to find similar candidates and then do one technique on one and one on the other and see which one works out better. So there's situations where you want to do this kind of paired design, or a matched. It's not the same person twice or whatever. So that gives you a couple different examples of how paired designs look, and then in later lessons we'll see how to do statistics on paired design. But this is sort of focusing on the study design.